think it's me.
Yeah.
All right. Shall I go ahead?
The web link worked. The web link got me in, but the using Zoom on my desktop, no, doesn't come in.
Okay, we'll tell people to use the link. Click the link.
All right. Folks able to see my screen?
I see your screen.
All right.
Yeah. Yeah.
Okay. Let's get to it. So µEforth. What actually prompted me to work on this was wanting to prepare a sort of a spruced up version of Dr. Ting's µEforth and C for Arduino for the robot boards that are eventually on the way. But in the process, I got to thinking about something last time or time before after we had talked about µEforths in C, and it occurred to me that there was too much C. And so I set about the thought that maybe I could try to minimize the amount of C code. A lot of the content of the latest rival prior to this of Dr. Ting's µEforth was that he was building up the dictionary in C code. So you've got sort of nearly forth code, but not quite. So my focus was to try to minimize the C code, but avoid redundancy. And in particular, there's a facet of ColorForth that sort of partially inspired this, which is I got to thinking that, part of why the ColorForth interpreter is so simple is the pre-parsing. And because of pre-parsing, it's able to sort of chew through and process individual words without a lot of fuss. It's just a dispatch table. But more importantly, it's really just chewing through and processing words. So we'll go into the details of what I actually did in a second, but I wanted to support a range of platforms, partially because when I've been doing things for Arduino, it's actually a pain to flash it onto the Arduino every time, or on ESP32. But while I was at it, I thought, well, I'll see if I can get Windows and Linux, and web is work in progress, but I'll tell you about that. And Dr. Ting has had much more luck with that, which he'll tell you about later. The approach that I took just for convenience was to chop things up a little bit. For Linux and Windows, I use pound includes. For ESP32, we found it most convenient because the ESP32 tools are very sort of inconvenient for folks to install, to have folks install Arduino and then use those tools. For those, it's easiest if you have everything concatenated into a single big .ino file. And so I have a script that goes through and does that. And for web, there's some regexes, which we'll talk about. So anyways, in this forth, it's sort of, it is similar to other µEforths. There's a small set of core words. I made some minor tweaks, partially out of personal proclivities and partially out of some things that I wanted to do. I kind of like throw catch, and so I re-added back in an explicit stack and made. But other than that, it's fairly standard. One other kind of weird thing was that I rather than having a bunch of the low-level arithmetic, the separated arithmetic, I just did /mod, which is a mixed bag, but we'll talk about that in a sec. So as I talked about in one of my prior presentations, I was able to use X macros for the core opcodes. So this is a trick of C macros in which you can sort of have a table of things that you want to use multiple times, maybe once to build up the dictionary, and then once to sort of lay out the code, a series of unique identifiers for each thing. And so each opcode is just sort of done on one line. And so these two screens, this is the sum total of the opcodes in the system. So it's, to give you a sense, it's not very many of them, and they're just all kind of little C one-liners. And then the actual structure of the interpreter, I used computed goto. So there's a next that's basically doing what you would do in a typical threaded indirect threaded forth, but do it in C. And there's a couple of words that I have to forward reference, And so for those, this at syntax is the, the reference to the label that I put them in on. And then this is actually what uses the macros to pull out the full interpreter. So you build up a pass to go and build up the dictionary with, and then you have in this piece here, you're just going and laying out a series of labels with the code for each word and then a next. And so that's sort of the core of the thing. And then to start the world going, I just allocate a chunk of memory, and then there's also a boot, which we'll talk about in a moment, which is just a string. So there's a big string that just has all of the high level definitions at that point. And so you're able to go through and parse this. Now there's a piece I've skipped over here, which we'll talk about next, which is to have this work to bring up the rest of the system. And it sort of goes on, and it's about 200 lines, I think, if I remember correctly. But there's about 5 tricky words that are kind of necessary to get the ball rolling. And so this is sort of these 5 words, and some of these are kind of quasi non-standard, are the ones that I did in C to allow me to then have the rest of the system be in forth. Aside from so there's the opcodes that I just showed that are very simple, and then these 5 are more complex. And so, right, you need to be able to parse, you need to be able to convert things to numbers, you need to be able to create a word, you need to be able to find a word, and then you need to sort of evaluate to plug one round of this all together. So this is analogous in µEforth to, like, it's able to load in a single word, decide if it needs to treat it, as a red word, a yellow word, a green word, something like that. So there's a little bit of an interconnect between C and the outside. I assume that I've got a set of a few variables, the translate input buffer, the position for the heap, a few things that have to be communicated from C to the interior forth, and the layout of this struct is assumed inside. And then so parse is straightforward. There's three variables that are communicated with C that allow parse to happen, and this is it, sort of parse in C, using these variables that are shared with the inside of the forth, and it's not too bad, right? You're just and the nice thing here is this is a word where I can treat it as an opcode because it doesn't have any error cases that need to do anything. The looping is interior to the word. And then similarly for numeric conversion, base is shared in common with the system, and then I can also do this although there's a loop here, I can treat this like one opcode because it comes back with a single result. Create was convenient to have. It's not, strictly speaking, something that would have been hard to build up from lower level things, but it's necessary to be able to do evaluate. And so it's also fairly simple and straightforward to do inside. And here you'll notice that where with parse, I've tried to keep the parameters kind of light. Here I don't care because create is mainly being called inside of from the others. So and then find is also relatively terse. It just needs to go up and do some matching on the words. And then the bit that glues it all together is the sort of non-standard thing called evaluate one, and this evaluates parses a single word and evaluates it, and depending on the state, so it'll do immediate words or it'll do number or whatever, but it does a single one of them, and then and it's a 2-pager, unfortunately, but it's basically just calling the others. So it's doing a parse, it's doing a find on that word. If it finds the word, it depending on the state of whether it's an immediate word or it's in the appropriate state, it will compile it onto the heap. Otherwise, it will the return value of this one is a thing to call, and that allows me to turn this also into an opcode that has sort of a single entry and a single exit. And then I'm able to build up quit without these words. That quit just gets built up as sort of the sort of proto quit, as it were, is a single evaluate one opcode and then a branch back to repeatedly evaluate. And then later I have a proper quit that I can wrap in in a catch call and all of that once those things are built up. And then there's the case for numbers and that's it. So that literally was all, like you've seen on the screen, basically all the C code. So yeah, there's one other, actually there's one other one. So */mod is shockingly hard in C. The issue is just that depending on if you want to have actually double wide things, especially if you're on a 64-bit system, there's kind of mixed levels of support. Doing it in high level C is a pain. And this, especially if you want to get flooring to 0 sort of right as per the standard, that's at least my preference. So this one's kind of a bear of an opcode, ended up being a 3-ladder. But aside from that one, which I'm torn about because it's not strictly necessary for most of the rest of the system, but it's sort of it's a very nice word to have and not have to do in high level words inefficiently. So anyways, this is the grand total, just barely under 300 words for the Linux version for the C code. Now that's excluding the lines of code for the rest of the bring up of forth, which is all just forth embedded in strings. And the boot portion is like 200 lines of forth code on top of that. But then there's a question: how does a thing like this talk to the outside world? What about I/O? For Linux and Windows, dynamic linking was the solution I latched to. So I had one more opcode on Linux, DLSym, which lets you pull in a dynamic symbol from a shared library, and that lets you, in high level forth, pull in all of the other words. So you can pull in, read and write syscalls. You can pull in sort of anything else that you might want to bring in, X11, things like that. And actually, you technically need DL open and DLSym, but DLSym will by default let you pull in symbols from the currently loaded libraries. You can actually use DLSym to pull in DL open, and I actually go and do that in the high level code. And then similar idea on Windows. You need two. You need to be able to do load library, and then get proc address will give you the address of a symbol dynamically, and so then you can get access to all the other things that you need to be able to talk to the outside world. You need one other thing, which is you need a way to call into C routines. And because the forth sort of, I don't know what registers the compiler will have picked, I need a series of words that know how to call into functions with various numbers of parameters. And actually you need up to 10 of them if you want to call into things like X11, where they actually do have functions with 10 parameters. So it's quite a pain in that. And then on Arduino, or rather on ESP32 through Arduino, I have a slightly different problem. There I've actually had to have explicit dispatch to each of the words that are relevant, because Arduino, it's all statically linked into one big thing that gets deployed onto the system. So there's no, you need to reference all the things you're going to reference. There's no OS to pull things in from. And so I pull in a bunch of things, kind of like this is an example of serial. And these go on because for quite a while, because I want to pull in sort of all of the useful things for ESP32. So it has for next. I have do loop in high level forth, but low level it's for next. I have tasks and streams. One reason I have this is because I wanted to be able to have a mode of operation where I can use it across the web. And so I wanted to have a way to have that be in a background task. And so some of that is there in high level words. I've got defer is and value too. On Linux, I've got the start of X11 bindings. It's able to like pop up a window and some simple things. It's nice to have it for testing, especially Linux, because I can sort of interact with it. Maybe I'll start using it in place of µEforth for some things. We'll see. On Windows, I have enough Win32 plumbing to spin up a console, because I'm actually starting up with a bare Windows app that doesn't even have the terminal. And so just to get a console actually requires a number of calls. I've got message box. I haven't bothered yet with GDI and like trying to do any real Windows. I made an icon using Forth Haiku, so it has a bit of an icon. I hit an interesting stumbling block, and especially this showed up as I showed some of this to the Forth 2020 folks. Windows has gotten to be more of a pain than it used to be, especially since the last time that I've done anything substantial there. Windows Defender loves to flag things as viruses, and while I'm relatively confident that I am not, spreading viruses, but I believe what is going on is that unfortunately, programs that have very tiny amounts of actual fixed source executable code that load a lot of things from data, that allocate chunks of memory, and then use dynamic linking to call on all of their symbols, look suspiciously to Windows Defender as malware, because this is how viruses and Trojans hide their sort of malfeeds. And unfortunately, a lot of modern antivirus have gone in the direction of they literally use machine learning to like suss out, does this look like a kind of virus? And so unfortunately, Forth looks like a virus. And this is not just a problem that I've had. I learned actually after the fact from that apparently the Win32 Forth folks have actually run into this, and they've had sort of a back and forth to get around this. One possible solution is that if you have a signing certificate where you've actually, ponied up to pay a regular fee to have your thing signed, you may be more able to harass Microsoft and other antivirus folks to whitelist your the things that you have signed. I haven't exhausted that path. I've fiddled around and found that if I build with, so I originally built with MinGW, which worked great in terms of being able to have it be one for one identical with the Linux version, because I could use computed go-tos. Switching to Visual Studio, I was able to, I had to switch to using switch statements, and that helped in the sense that the 64-bit version now is able to pass by Windows Defender, but the 32-bit version is still angry. In general, I'm actually kind of saddened by this, because it's alarming to realize that it has now become sufficiently challenging to do an interesting program distributed on Windows without sort of being part of the full ecosystem, buying a certificate, not maybe even distributing it through the Windows Store or something like that. So it's a little bit alarming how bad this has gotten. So just briefly, I changed around the interpreter on Windows to build up a list of symbols, and then use a switch statement, which is a little more complex, to replace the interior core. And this seems to tickle things a little bit less badly for whatever reason. It looks maybe less like a scary obfuscated virus. I'm curious if folks, one thing that has also got me wondering is how important Windows is to folks. Like I am on a Windows box at the moment, but I actually use the Windows subsystem for Linux. And I'm kind of curious the distribution of folks attending SVFIG meetings, sort of what OS do you use? Are you, if we've got a lot of folks on Linux or sort of marginally indifferent to Windows, maybe I don't invest the effort. So if you could please type, the type of OS you're using, the version, if you're willing to share, I'd be curious to look through that in the chat and sort of gather up a tally, and I'll maybe add them up and maybe send out a summary to folks if folks are interested in seeing the aggregate. I have a web version in progress. I won't spend too much time on this. I'm trying to transform that set of opcodes into ASM.js, which is this stilted form of JavaScript that lets you express code that the JavaScript engine will actually convert to very efficient machine code. I know about this because I was one of the folks that actually implemented this in Chrome, and it's kind of a little bit ridiculous and weird to be generating code to try to pass your own validator. You have to get the syntax just right, because it's not really meant to be human readable JavaScript. It's meant to be JavaScript the machine can transcribe. Doesn't run yet. Maybe I should be using WebAssembly, all kinds of things there. Amusingly, Dr. Ting has beaten me to the punch on this, and has a rather nice thing that he'll be talking about later, done actually in high-level JavaScript, which I think maybe is, in hindsight, the right choice here. There's a bit of an impedance mismatch doing it this way, but this is what ASM.js looks to give you a sense. It's not pretty. So on ESP32, I've got lots of things working. I'll demonstrate that if I'm not too terribly over time here. I got it running on ESP32. I actually got an ESP32 cam. The camera, which you can probably barely see my screen. You can't see my screen. Anyways, it's a variant of ESP32 with an eensy little camera, like less than a centimeter in diameter. And it also has an SD card, which is nice. I've got bindings for allocation, for Bluetooth serial, GPIO, I2C. I've got support for files and SVFIG, and I've got Wi-Fi and a web server that can run on there. I can pull frames off the camera, although I haven't actually vetted that I'm getting real data. Like you can get raw JPEG data. So I've got the bindings there, and I've confirmed that I call the calls and they return a value, but I haven't actually done the steps to pull them off. But that'll be next on my list. So I'll probably be working on more bindings. I'm missing, so I have Bluetooth serial. This is like old style Bluetooth, not BLE, but I don't have bindings for any other kind of BLE. One thing I've just found myself wanting here is I may want a serial editor because it's actually kind of tedious to interact with things sort of and have to compile it in. It's nice that there's SD storage on the then I don't have to solder on my own. So anyways, let me do a quick demo. So I'm gonna plug in. I'll show the question. Let me show quickly so this is the Windows version. I'll fire up and it ran on the other screen. So pull over here. So it's got a lot of words. So one of the words I've added in, it has a FG and BG for foreground and background color, and so I can loop and produce lots of colors, for example. So that's sort of this is just the standard Windows terminal, but with a bunch of things. It has there is a crude version of C, but you see sort of low-level things. So that's that one. I won't show the Linux one because it's much the same. But let me go ahead and so I got the board. I'm going to plug in the board and talked it over the serial terminal. As you can, let's see. So it shows up on. Oops! It shows up on the other window. So it boots up and you get a fourth prompt and you get all the words. There's quite a few more words here because on Arduino I've got bindings for all of these various things that are built into the Arduino ESP32 stack. One of the things that I've got here is I've got it mounting. So I have an autoexec.fs that gets loaded on start, so it's mounting the SD card on this device. So I'm going to be able to do /SD card. What did I call it? Serial bt.fs, and I can do include it. And so then, oops, what did I do wrong here? Error. That's not. Let me reboot it just to see if it can not mount properly. SD card, there we go. Demo fail. So that will. It's not connected because I rebooted the thing. Okay, so words, good. SD card, serial Bluetooth, FS included. So that's the MAC address of a device here. And so now it's connected, and because I've got deferred words for type and key. I've got a word here. Let me see if I can do C BT on. So I've got this word that will you can't really see the interior of that, but it will route keyboard and input to Bluetooth serial. And so now it's gone dead over there, but I can turn on my phone here. I've got a Bluetooth serial terminal open here, and let me connect. And I don't know if I can see this very well, but I can do words. I've got the connection over here. And then I can pass the baton back if I do BT off. on the serial terminal, and then I'm back in business over here. So I can go one or the other. You can also connect from the PC, but I thought the phone would be a cooler demo. Let's see. I think that's the extent of what I'll show now. And let me, in light of the time, let me go ahead and take some questions. And there's a bunch of information about it at eforth.appspot.com. So I got a proper website with a bunch of documentation of a sort for once. I see there's some stuff in the chat here.
No. Go to your place.
But please chime in on, because it'll take me a second to skim through here. Got rid of okay, we got the survey of Windows systems. Have you tried porting Forth implementation into C directly into Firefox interpreter bypassing JavaScript? I mean, not quite sure I understand the question. You can, I mean, there is, so WebAssembly lets you compile targeting sort of kind of indirectly into the system. ASM.js is another path where you could actually use a set of a tool chain to produce your ASM.js. You don't have to do it by hand. The tool chain is quite a bear to run though, and I'm loath to do that for Forth. If you mean directly modifying the browser, that seems particularly roundabout. But yeah. And my memory management. So I do pass along malloc and free over to the device, but I actually use a conventional Forth heap. So I do a big on Linux. I do a big mem map at the beginning to give myself a big buffer, and then use a lot throughout to do allocation. But I do pass over malloc and free. The main reason being that there are a few data structures in the Arduino interface where you might want to have access to malloc and free, because they're doing allocation using the C heap. So the C heap is there on Arduino. On Linux, I'm literally not using it for anything critical.
Okay, Brad. Yeah, I see all your code, but couldn't understand any of it. Okay.
Uh-oh. That's not good either.
Yeah, I think it's too deep in the sea. But I am glad that you've done it, and we'll study it and see how I can get to understand it better. Thank you so much, Brad.
Good. Thank you. I can figure out where the button is to unpresent. There we go. Stop sharing my screen. All right, back to you, Kevin.
Okay, can you hear me? Can you hear me now?
Okay, yeah,
Yes.
sure.
Okay, I'm having internet troubles, so I may have to bail out. Dave Jaffe, can you take over chairing the meeting if I'm not here?
Yes.
All right, if I'm not here, Dave's in charge. Ting, you're